So yeah, is good. Hey, hi guys, I guess you guys are able to see me, or let me do some adjustment over there. Let me see how many screens we have. This one is there, Binary webcam. This one is also there, Chrome webcam. This webcam. Integrated with this. But this screen is not working. Let me just fix it right quickly. Webcam, Chrome. This is fine. YouTube live streaming. Robber. This I want to put. This one is looks good. Webcam, why not it's working? Final webcam. One time I can see here it's working. My this webcam is not coming. My video capture is got it. Okay, now here we go. Yeah, so we done the setup. So I am actually doing the setup in very first time. So there maybe here and there I have done so that's the reasons I need to just get everything to be fixed. And also let me connect with the space desk once. We just quickly do the setup, guys. Give me like 5 to 10 minutes. And meantime, please share the links to your friend circles who can available, and they can join also. We will going to take some live question also. So this one is also fine. Looks good to me only. Then we have this screen. Yes. So just guys quickly mention on the chat, are you guys able to get the audio perfectly, along with the, you guys able to see my screen and able to see me properly? So these three things just quickly confirm. You guys able to see the screen that I am sharing? You guys should be able to see my face, and along with you guys get the audio correctly. Just quickly confirm. I'm just waiting on the chat. So just put yes if things looks good to you guys, or if there is any adjustment then we can correct accordingly, right? So I'm waiting, guys. So just quickly mentions you guys are able to see on the setup parts, it's looks good to you, like you guys are able to access the things correctly. Okay, I got one confirmations, right? So I hope that things looks good, then we can eventually start it, right? So or we should wait for another 2 to 3 minutes. We can We can wait for another 2 minutes. We will start at sharp 1925, right? We will start at sharp 1925. Just 2 minutes to wait. Just 2 minutes. Able to write also properly. We should. Yes, on setup part I am very good to start. So yes, yes guys. So let's start. Otherwise we are going to take the things on more uh, later night part. So I am just want to make the things on the timings to be on the correct. So there is a timing delta, I guess. So we previously announced we will do the live on tomorrow, actually on 15th August 11:15, but due to a change in plan, I decided to do it now today only, because on tomorrow I might not going to available, so want to do it today only. Yes, so with this, I think I have shared the links to all of you guys, and please share who are basically looking, watching this. We will, so the main agenda of this today's video is we will do an in-depth binary search for uh, like basically do the in-depth binary search in one shot. So what's the agenda? So we will basically uh, do we'll basically understand why binary search we have to learn, and eventually uh, we will understand some of the like real benefits, like real world benefits that we are basically getting on using the binary search. And then eventually we will solve five real world problems. So I guess you guys already have the access of our this DSA practice sheet, and on this DSA practice sheet there is a group of problems on binary search. So binary search, binary, where is this, where are our problems are, yes. So this is the set of problems, 1 2 3 4 5 6. So these six problems we will eventually try to solve. So not all the six. I think I am not going to solve this hard problems, that is median of two sorted arrays. And why, the reason is not going to get basically go to on that much difficulty. So this basically needs a very like kind of a here and there maths is going to be involved. So it is very little chance you are going to get these problems, this at least the medians of two sorted arrays, these hard versions. But again, like based on like you guys ask, I will maybe create a separate video, or on like separate live we will eventually solve these problems, but on not this today's video, today's live, because else it is going to get like too long to basically run the streamings. And apart from that, all the five problems that we are going to solve all are like industry standard problems only. So you are definitely, for sure, you will definitely get a very good understanding from this. So I think you, all of you guys have the access of this sheet, but if any one of us don't have the access of this sheet, I am just going to share to you guys also. I've shared. So how I can share about this line, I remember to your quadrant this string widget. So mostly give me 1 minute. Maybe on this chat, do I have the access to share? Live chat, learn more. This, okay. I think here I am not getting the things to share. But yeah, maybe I will figure it out. Maybe I will share this to you guys offline after the videos, but mostly I am assuming that you guys already have the access of this sheet for sure, right? So yeah, with this note, let's just quickly start on this. I think we are on 15 minutes running late to our time, so let's not wait further. So let's just start on the video, right? So give me one minute. What happens here? Give me, make it as smaller, and then you can go to this. Yeah. So why actually we have to think about the binary search. This is kind of by names you guys are getting, by names only you guys are getting that it is a kind of a searching algorithms for sure. So in these algorithms, like on the binary search, on very naive, like very naively, like you guys are getting these things that binary search means we have to search some things, we have to search some things. Now on searching, there are two popular algorithms in the market. First one is a linear search, right? Linear search, we all are aware. And second one is the binary search. Second one is the binary search. Now what is the advantage? What is the advantage of linear search? What is the advantage of binary search over the linear search, right? So the thing is on linear search, if on an interview someone is going to ask you what is the advantage of linear search over the binary search. So on linear search, you can run it, you can run it to any data set, any data set. You can run your data to any data set. But on binary search, there are few constraint. What are the constraint? Your data set should be monotonic. So I on in and general, I have to write only one mandatory statements for binary search to be put to your data set. Your data set should be monotonic in nature, should be monotonic in nature. So this is the statement you have to put to your interview, that is, it should be in monotonic in nature. So I saw like people are putting, if I have a sorted list, if so in sorted list, it can be either increasing, it can be either decreasing, it can be either increasing, it can be either decreasing. So it is not going to make any proper sense if it is a monotonic increasing or monotonic decreasing. So by increasing or decreasing or by sorted, it's basically narrow down, your thinking. But if you are going to use this term, it should be monotonic, in nature. It can be either monotonic increasing, either monotonic decreasing, anything. It can be any of those. It can be either monotonic increasing or it can be either monotonic decreasing, but it should be monotonic in nature. So this is one point. And second point is, if it is monotonic, when let's suppose this is our search scope, this entire things is our search scope. This is our search scope, right? So in our search scope, what we will do, I guess you guys should know on very high levels how actually the binary search work. But those who don't know, I will go to very naive, like very basics I will going to try to cover. But yeah, those who know, who can just correlate, we are basically try to omit one of the search space. We will, if that is my left boundary, and that if that is my right boundary, we will define our meet to be just in between of my left and right, and we will eventually trim down one of one of our search scope. We can either trim down my right subset, right search scope altogether, or then my list is going to be become from L to mid for my next iterations, So, or I can either trim down my left search scope, then my next search scope is going to become from mid to R, So that is on the high levels binary search is working, but we will definitely go to very depth now. But the main reasons, so the first things, your search scope should be monotonic in nature. And the second point is, you should eliminate your either left part or either your right part. You should be able to either eliminate your left part or your right part for sure. Right. I think these things is very clear. To you. Right. If you understand till this point, please provide a thumbs up on the chat. Then we will go further. Please add a thumbs up. I'm waiting. So once you understand, just please add a thumbs up on the chat. Like till this there is no doubt, or if you have, please feel to ask this. So the main agenda of doing live, so that you guys can ask your doubts on here only. So that is the main agenda. So if you guys by chance have any doubt till now what we have just discussed, on high levels what is the linear search and what is the binary search. Binary search is going to give you some advantage which we still don't know, but we will eventually understand. And linear search, we can run it to any kind of data set. We can run into any kind of data set, right? So yes, I see the thumbs up from you guys. So I can then move further. Right? Till this there is nothing like complex with it. Right? Fine. So now what actually binary search is doing. So binary search, we understand it's working on monotonic data set. So on high level, so if I am going to compare with its to a linear search, then if my elements, so let's consider we have 1 2 3 4 5 elements, right? Let's consider we have these 5 elements. So, and this is, let's consider our targeted elements. So on linear search, we will iterate from left to right. Let's consider it 0 and let's consider it to n-1th index. So we will iterate from our I pointer from very left to right, and we will check or at which index we got the match, and then we can eventually return, or whatever the requirements, as per the requirements, you can play your game, right? Clear, right? Very clear, right? But so the problem with this, so there are few cases on time perspective. I guess you guys has already went with our time complexity video. If you don't went, then, and if you don't have the understanding of time complexity, so it is basically hardware independent. I would highly suggest to go to that video. That is very in-depth discussions like we have on time complexity, how it is working. But on high levels, I am just stating time complexity is basically working on hardware independent. So there are 3 cases as far as I remember: best case, good case, best case, like average case, best case, worst case. What are those? First one is best case, second one is like worst case, third one is like average case. So now how it is working? So best case means the elements that you are searching is at very starting, at the very start index, and you are iterating from that direction only, you will get it at very first go. Worst case, very last, getting it very last. Average, in between some middle point, in between some middle point, right, in between some middle point. So average case. So this is the on high levels, these cases are actually means. Now let's consider the elements that you are searching is all the case, is all the time in all the test cases are lying to the very end. Then on an worst case, so always think about worst case, so on worst case I will be ending up of consuming the, to check our entire data set, right, entire data set, because we will get our match to at very last, right, we'll get our match of the data set at very last. So now that is the main disadvantage of, that is the most I have to say, that is the kind of disadvantage of linear search. So now just start the discussions over the binary search, but the power of linear search, it can work on any kind of data set, no matter your data set is monotonically is kind of a monotonic in nature or non-monotonic in nature. Linear search can guarantee you to give the requirements which you are looking for to your either monotonic or non-monotonic dataset. But binary search should, why I am repeating these statements repeatedly, guys, because that is the point that you guys have to understand. So binary search will work only for which dataset? Only for monotonic dataset. So now consider a very basic example. Let's suppose we have a monotonically increasing list 1 2 3 4 5 6 7, right? And let's suppose I am going to ask you to find the index. You guys know it's starting from 0 1 2 3 4 5 6, right? If I am going to ask you, I am going to provide you a target, give me the index of the target elements where this element 6 is present to your list. If it is not present, then return me -1. So let's suppose we have these problems. Then okay, by very brute you can iterate from left to right and find the index where the element, the target, is basically lying, right? But here we are proposing, okay, my dataset is monotonically increasing in nature, and it is monotonically increasing. First observations, monotonically increasing. Okay, when you have these observations, now it is more than sufficient. You can think about on binary search direction. So now how it is working? How it is basically working? It is basically working with the principle of divide and conquer. The principle of divide and conquer. So on divide and conquer, what we will going to do? We will set my initial search scope is of size left to right. I will put 2 pointers, one is left and another one is right, and we will define a mid by doing the left plus right by 2 to identify my mid. So here in this case, my mid is going to be identified as this. Now I am going to check. I know my left portions is sorted, my right portion is also sorted, and they are in monotonic nature. So I will check if the mid where I am basically lying right now, where I am lying on this 4 I am lying. So I will basically check, is this 4 is more than my target, Then if this 4 is more than my target, then I know I have to go to some smaller part. I have to search to my smaller part, because this 4 is more than my target. But on this case, the target that we are looking for, the target that I am looking for is more than my 4, is more than my 4. So that means we have to search on the right side, right scope, right subset, not on the left subset, because the mid is altogether smaller than my target. So I know if my mid is smaller, so the condition is if my the mid is my smaller than my target, so I know my left portions is sorted already. So do I have to go to search the elements to my left part or right part? Where we have to go to search? Where we have to go to search? I know if my mid is altogether smaller, then do we need to go to the left? Do we need to go to the left portions? No man, because my left portions is already holding more smaller elements which are less than 4 itself, and 4 we have just identified is less than my 6, less than my target. So we have to go to my left subset altogether. No, not making any sense. Then omit your left portions, entirely. So now on my next iteration, so my first iterations, my search scope is from L to R, that is my entire of size n. I am searching on size n, and on my next iterations, I am going to search from mid to right, so that is my search scope. So my search scope is going to reduce to be n by 2. So whichever the elements we have now, so we have now 5, 6 and 7, right? So now your left is going to be now this, and your right is the same ones. Define your mid. We identified our mid. If my mid is the target, yes, return. So how many iterations we found? How many iterations we are able to find it? How many iterations we are able to find it? In 2 iterations. In just 2 iterations, we are able to find it. Right? So, but if we are doing linear search, then first iterations not a hit, second iterations not a hit, third iterations not a hit, fourth, fifth, sixth. So on sixth iterations we are going to find it. So that is the advantage. So we are able to find it in kind of 2 iterations. Now let's just quickly build a concrete time complexity with these observations. Can we build? But so maybe you guys think about, if the elements is the very first elements, then maybe binary search is going to take more iterations. Absolutely right guys. Then my first search scope becomes 1 2 3, then identified mid, no match, trim search scope 1 to 1 search scope, hit, return answer. So first iterations we have n, these iterations we have n by 2, these iterations we have n by 4 kind of search scope, right? So on third iterations we are going to get 1, but on linear search it is going to return you on very first it will going to find, right? So on that case linear search is better, but I am going to give you, we always have to think of on worst case. We just discussed 3 cases: best, worst, average. So we always have to think of in kind of worst case time complexity. So on worst case also, if so what is the worst case in terms of your linear search to find this 7? So let's just try to find this, to find that 7. My linear search is going to for sure going to take how many pass? 7 pass. Now let's just define for binary search what is the is there any improvement? First, we know I'm not going to rewrite it again. So you guys already saw after first iterations my search scope becomes from 5 6 7. On very next iterations my search scope becomes only this 7, right? So 3. So any case on any case the binary search time complexity becomes how much we will define, but it should be on worst case binary search is guaranteed you. On linear search worst case binary search is going to guarantee you to find it in for sure some less time, for sure some less time. So linear search time complexity, I guess, is very clear to you guys. If you have basic understanding of time complexity, then you guys can correlate. So linear search, if I have a size of n size array, then the time complexity is, it is going to take off big of n. Why so? Because it is going to search to all the elements at very worst case, and we have n size array elements, n size array elements. But on binary search, what is the time complexity? What is the time complexity? You guys, some of you guys already know. Some of you guys is already know, right? Some of you guys has already like kind of a like pre-digested. It's for binary search. It is going to take off. Binary search is going to take off of big of log n. But don't know how we are basically defining these things. How we are basically defining this big of log n. To basically define it, it's very simple, guys. It's very simple. So what we just understand here. So what we just understand here. So initially on, if I am going to write it, let's not take this. So if I am going to write my iteration, so that exactly we have to find how many iterations we have to do. That is my time complexity. My iteration and search scope. If I am going to create a table with this, I have two things. On left I have iterations, and on right we have search scope. So on very first iterations, what is my search scope? Is n, right? So when we are at zeroth iterations, I am basically giving it the indexing in kind of zero based, right? So when we are at kind of very start iterations, my search scope is n size. Next iterations, my search scope is going to boil down how much? Tell me, guys. N by 2. Correct. On next go. Second go. What is the previous search scope is n by 2. We are going to reduce to its half. To its previous search scope ka half. To its half of its previous search scope. My previous search scope is n by 2. So n by 2 ka 2. N by 2 ka half. Half of n by 2. It becomes n by 4. Next times. Third. N half of n by 4. N by 8. Next. N by 16. Can we define a formula? With this? Can I write it? N by 2 to the power 0. Right? Can I write it? N by 2 to the power 0. Can I write it? N by 2 to the power 1. Yes. Can I write this? N by 2 to the power 2. Yes. This n by 2 cube. This n by 2 to the power 4. So what is the iterations count? So this is coming as the power. Now let's suppose my iterations are going to get ended at kth time. So what is the search scope on at kth time? N by 2 to the power k. Agree guys? Right? Agree guys? Now we just saw when we are at our minimum search scope. What is the size of our minimum search scope? What is the size of our minimum search scope? What is the size of our minimum search scope? Can any of you guys tell me what is the search of our minimum search scope? Can any of you guys tell me what is the size of our minimum search scope? Anyone? I'm waiting for 1 minute to get you guys response. What is the size of our minimum search scope? Anyone can tell me? Anyone? Can anyone tell me? Can anyone tell me? Can anyone tell me? Quick guys, quick, 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 quickly, quickly, quickly tell me guys, quickly tell me. Anyone? Anyone? Yes, yes, yes. The minimum search scope is going to be 1, is going to be 1, right? 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 My minimum search scope, the size of my minimum search scope, the size of my minimum search scope is 1. And we defined at kth iterations we will have my minimum search scope, we will have my minimum search scope. Agree guys? Agree guys? Then can I write the formula? N by 2 to the power k is nothing but 1. You guys just told me. You guys just told me. Yes, yes, absolutely yes, absolutely yes. Then just do a simple mathematics. N equals to then 2 to the power k. Can I take log both side? Take log. Log n. Log of base what? Base binary. 2. 2. Base 2. Log n base 2. Take log on both side. K is going to get coming further, right? If I am going to take log. Log of 2 base 2. Log of 2 base 2 going to get cancelled. So log of n by 2 is becomes k. Are we finding k value? Are we finding k value previously? Are we finding k value? So k means is basically my iterations count. So what is the iterations count at very odd case is nothing but k equals to log n base 2. K equals to log n base 2. Proved. Proved. Your time complexity is proved, man. Your time complexity is proved. So that is the time complexity at very odd case binary search is going to consume. If you guys are able to understand, then please do, please chat on the ud understood, understood, anything, please put an ud understood, or if not please mention. I will reiterate to you guys. Right. Please put a ud. Anyone putting an ud? Waiting. Anyone putting an ud? Or if you guys not able to understand any part, please then please do a comment, because that is the time guys. Because on next, if you have any doubt, I'm not going to get it answered. So if you have any doubt, so that is the ideal time when where at which time you guys can at which time you guys can put your asks. Right. Right. So just put an ud if you are able to understand. Repeat. Okay. On which part? Which part? On time complexity part? I feel so because that is the complex part we did. We got one ud, one repeat. Okay. We can do a quick repeat. For sure. Right. So let's just do a quick repeat. So where we are. So yes, H, your name is H, or what your name is? Your name is H only. Okay. So what we just discussed, so if I can make the theme a little smaller. So to define the time complexity, just turned in, what are we doing? Okay. Okay, so what we are doing, man? So Dogbox, I think that is the names that you have put. So what we are doing actually, we are basically defining the time complexity of our binary search, right? We are trying to define the time complexity of our binary search. So for that, we have tried to generalize the things. What we are trying to do, we are trying to generalize the things. So when we are at iteration count 0, so we are starting, we have iteration count on my left side, and on my right side we have the search scope. So what I am stating, when when we are at very start iterations, so on that times we have a search scope of size n, right? Then my binary search is going to eliminate one of the half, either left, either right. That we don't have to care on time complexity definition. So we just omit one of the half, and and I have a data set of size n by 2. I have the data set of size n by 2 on 1th number of iterations. Similarly, on very next iterations, again we are going to eliminate one of the part, either left, either right, either left, either right. So n by 2 ka half, we are eliminating one of the half, so it becomes n by 2 ka half, again n by 2 ka half, so that means n by 4, on third times we are again trying to eliminate one of the half, to whom n by 4th we are going to eliminate one of the half from of the data set of size n by 4. So we are going to land off of size n by 8. On fourth iterations it becomes n by 16. So like this way we are trying to define a formula. It's nothing but n by 2 to the power 0. So when we are at 0th iterations, n by 2 to the power 0. First iterations n by 2 to the power 1. Second iterations n by 2 square, n by 2 cube. Fourth iterations n by 2 to the power 4. So we just correlate whatever the iterations count is going to go to on the right part as n by 2 to the power k. And my time complexity is defined how many times, how many iterations is running. So my time complexity is nothing but how many iterations we are running. So we just arbitrarily say we are running k iterations. Then my formula becomes n by 2 to the power k. Then from your guys input, from you guys all together, I got that my n by 2 to the power k, the minimum search scope becomes of the binary search. When we have only a single elements to search, my minimum search scope becomes of size 1. So, and at kth iterations, if the kth iterations is the last iterations, we are bound to get live with the minimum search scope. Then on that case, my n by 2 to the power k is becomes my minimum search scope. And what is the value of my minimum search scope is nothing but 1 only. So can I write this formula? N by 2 to the power k equals to 1. That's we write only. So n becomes 2 to the power k. Then we took log both side. Then we got log n, this log n base 2. So we took log of base 2 on both side, and it becomes log n equals to k. And so that means k equals to log n base 2. And k is nothing but our iteration count. And iteration count is nothing but my time complexity. So my time complexity is finally becomes log n base 2, which you guys are blindly doing, blindly remembering the formula, which is correct, but that is the mathematical intuitions behind this. That is the mathematical intuitions behind this. This is the mathematical intuitions behind this, right? I hope now this is going to get to crystal clear to you, all of you guys. Hope so, or not. or anyone have any more doubt, or anyone has any more doubt, tell me quickly, because these portions understand is very important, is very important, guys, because this is might be you guys going to ask on interview, but on rather than interview perspective, it's important to your like kind of what can I say, that your semester perspective, data structure and algorithm semester perspective, you guys going to maybe just get some question on this to define the formula of this, how binary search time complexity is big of log n. I feel so it's very clear, it's very clear to you, it's very clear to you, right? Okay, okay, thanks Dogbox again. Ramuglu, okay, you already understood. Okay, I think we are good to move, right? We are good to move. So what we have covered till now, we just understand how actually our binary search works, so that we understand. Then we understood why the two kind of searching algorithms we have: linear search, binary search. What is the advantage of linear search over the binary search? What is the advantage of binary search over the linear search? Which dataset we can use binary search? Then we have understand how binary search is on high levels work. It's basically working to you on divide and conquer algorithms. It's working principles we also understood, and we eventually understood the time complexity, the very popular log n base 2, we understood why it is log n base 2, the time complexity of binary search. So till these points I think we are very good, right? Now let's go further, so now, so that is the part on the binary search, you guys have to know now. So that is the part, guys. I am honestly stating that is the part you just need to understand. Post that you can first pick these problems. First we'll pick these problems and we will try to define our template. So the next agenda is now we will do some coding. Next agenda is coding. Now from here onwards we are going to start the coding part. We are going to start on the coding part, and I am highly encouraged to you guys to please share the videos to your friend circle who are now basically free and attend the live, because on live you guys can see, right? You guys can clarify your doubt one time, two time, thrice, multiple times. I am here only to clarify your doubts, right? So please try to ask your friend circles to attend the things if they are available, because on this particular lives we are going to solve some crazy problems on binary search, right? Some crazy problems on binary search. So now we will start on the coding part. So on coding part, I have just given you on very high levels how binary search is basically working. The working principle is we are going to take some left and right, and we are basically try to define a meet, and based on certain observations we will going to either left or either right by eliminating one of the search scope, and eventually we are going to land with a single elements, and on that single elements either my requirements is going to be satisfied. If not, then what is the fallback requirements? We are going to execute that. What is the fallback mechanism? Fallback requirements, we are going to execute that. Right. With that note, let's just quickly try to solve the very basic problems on binary search, that is of itself binary search. The problem name is itself binary search. So that is the problems is this problem, that is lead code on row 63 of our by DSA sheet. You can find these problems. I will share the DSA sheet to you guys. It's already shared. It's already like shared to you guys on our past videos also, where we have discussed our complete DSA roadmap. But I will reshare to you guys to these video descriptions also, and on the comment sections also, so you guys can access. So this is the problem. The problem is itself a binary search. So let's just quickly try to understand the problem. So on the problem statement, given an array of integer nums which is sorted ascending order, and an integer target, which we just discussed to our understanding purpose, the same kind of problems. Write a function to search the target in num. If target exists, then return its index, otherwise return -1. You must retain an algorithms of big of log n time complexity, log n runtime complexity. So that's the reasons we have to opt in for the binary search. Will linear search work? Will linear search work here? Yes, it should work, because my range is small, only 10 raised to the power 4. So we can write a linear search for sure. So how should be my linear search code? Let's just very quickly write the linear search. For I in, first define our range. N equals to my len of my nums. For I, so I am assuming you guys know some basic fundamentals of the programmings. Otherwise, maybe you guys not going to get the most of it, but eventually you will get how actually the algorithms is basically working. You just have to understand the algorithms. Codings is very easy, guys. With nowadays, with the agentic AIs, no one is going to appreciate codings. If you know the fundamentals, you will going to get the appreciation. So try to understand the fundamentals. So what we have to do, for I in range n, we have to iterate n times. If my nums of I is hit my target, is equals to my target, right? Then we can return our I. And if with the interlinear search we are not able to find any, return a -1, right? Return -1 on the fallback case they have asked for. Quickly compile, should work. Working fine, quick submit. The time complexity here is big of n. Why I am doing these things, guys? Because this is the fundamental problems. If you understand the fundamental problems, post that you can build your thinkings. You can build your thinking. So and we will define a generic template which we can use to rest all of the binary search kind of problems. Now it's working fine, it's accepted, but we will not going to go with this linear search approach, right? So what we have to do, what we just discussed, we need two pointers, one at left, another one at right. At which particular C++ better sir? Yes man, you can do codings to any of the language. The template is going to be exactly same. There should not be there should not be any change at all on template. You can do your coding at your favorite language. So it is kind of a algorithmic sessions, man. It is not a it's not a kind of a this compilers things. Like you can use any compilers, any programming language. The programming language is kind of a not restrictions of to basically get the intuitions of the algorithms. So focus on the algorithms, man. Focus on the algorithms. So my left pointer at 0, my right pointer should be at n-1. What is my largest search scope? What is the last index? Index are starting from 0 to n-1. Index are starting from 0 to n-1. Right? Then my algo should be while my left should be less than my right. While my left is less than my right. So I am within the boundary. Then define your mid. Mid should be left plus right by 2. You can write by 2 like this, but I am going to use this shift operations, this bit operations, because bit operations are kind of a faster than normal operators operations. So I am using the binary like bitwise shift of one index. It's nothing but same as if you are going to write it something like this. It going to exactly same. It's going to exactly same, but I am going to write it on this format because on competitive programmings you guys saw this kind of syntax, and it's kind of a faster for sure. So it is just a bitwise right shift, and it's going to divide your number by 2. It's going to divide your number by 2 for sure. Now what else? If my nums of my mid is equals to my target, the target that I am looking for, can I return this index itself? Can I return my index itself, mid itself? Yes, it's a match, it's a match. Elif. If my nums of mid is more than my target. Oh, okay. So that means my target is lying some smaller part, my smaller part. So and at which particular search scope then we have to go for? Which particular search scope we have to go for? We are lying at a mid, which is itself is higher than my target. So can I say I have to go to my left search scope? I can eliminate entirely my right search scope. Can I do? Can I say yes? Do it. Move your right to mid minus 1. Move your right to mid minus 1. And on the very else case, it is the target is lying to the right subset. Then eliminate entirely your left. Then do that. Left should be mid plus 1. That's it. And if my binary search is not able to return, find the target, so that means this target is not at all present to your array. Return minus 1 after your binary search is exhausted to search. Then you are very good state to return a minus 1. You are at very good state to return a minus 1. Right? Clear guys? Clear, right? Quickly compile. Working fine on the sample. Quick submit. Is it correct at all? Yes, it's 100% faster than all over the submissions over the lead code, and it's taking 0 millisecond itself. It's taking 0 milliseconds. Understood guys? Please type 1 UD. Understood. Please type 1 understood. Hey, hello, who is this? Gajanan. Hello Gajanan. Hi. Hello. Yes, those who are following, understood. So we build our template of binary search. We understand every lines of our binary search line by line, why each of the lines we are writing. We did a live coding, all the 5 problems guys. Again I am stating, all the 5 problems we will do live. We will solve it in live. So that's the benefit. And you can put your benefit, you can put your ask, you can put your question on the live chat. You can put your ask on the live chat. So that's the benefit to join a live sessions. Please guys, if you have any doubt, ask the problems here only. Because that is the best way you guys has the way to interact. So clear, right guys? The template, every line is clear, right? Every line is clear, right? If yes, then provide a thumbs up in the chat. If you guys are able to understand the things, able to following the things, provide any indication so that I can get the understanding that you guys are able to understand it. Anything, provide a thumbs up, anything. Understood. Recursion, this problem can solve recursion. Yes ma'am. Yes Gajanan, you are correct. We can solve with recursion also. You can solve it with recursion also. But yeah, again, like always try to solve. If you have the solutions for iterative approach is always going to get the preference. That's always be true, always, because recursions is going to consume a recursion stack trace space. It is going to consume, right? But iterations is not going to consume any extra space. So what is the, quickly do the time and space complexity analysis. Time complexity, big of, tell me, log n, right? Big of log n. Space, are we guys see we are using any extra space? No, it's constant. So that is the benefit, Gajanan. So that is the benefit of iterative approach. Gajanan. We are not going to take any extra space at all. The space complexity is constant. So but you are correct, man. You are correct. We can solve it with recursion for sure. But I am not going to fan of the recursions Never guys, or try to, if you are building a template and if you have like options, either go to iterative or either go to recursive, then always go to iterative template. It's faster for sure, and it is going to consume more memory. Right, it's clear, right? Till this point it's clear to you, all of you, because now from onwards we are going to catch some advanced problems. Now onwards we are going to catch some advanced problems. So the next problems that we are going to solve is search in a sorted array. If you understood the earlier problems, I guess all of you guys understood. So now, so this is kind of a medium problem for sure, and it's asked on multiple product based company is going to ask this problem. Search in a rotated sorted array. Search in a rotated sorted array. Now take your 1 to 2 minutes to understand the problems. I am just going to quickly iterate to you guys to the problem statement. So there is an integer array nums sorted in ascending orders with distinct value, prior to being passed to a functions. Nums is possibly left rotated, So we have the same array, but it is going to be distorted somehow. Why it is going to be possibly left rotated at an unknown index, that we don't know, but it is for sure left rotated, such that the resulting array becomes nums of k plus 1 something something, nums of n minus 1, then nums of 0, that is the index where it is going to be monotonically increasing. It becomes sum of the middle part, right? Then for example, this might be left rotated by 3 index. So this is the initial array we have, 0 1 2 4 5 6 7, that is the monotonically increasing array we have. And let's suppose it's going to left rotated by 3 indices, so it becomes 4 5 6 7, then 0 1 2, 4 5 6 7, 0 1 2, right? You guys are getting, right? So first left rotation, this 0 becomes going to end to the end. Second left rotations, this once is going to end to be end of the array. You guys are going to get it, right? Or else I am just going to quickly iterate to you guys to this, what I am just stating here. Give me 1 minute. So what I am stating, man, so I am stating, so how actually the left rotations they are basically signifying. So let's suppose we have an array. Let's suppose we have an array 1 2 3 4 5, and let's suppose we are going to left rotate by 2 portions. First left rotations, it becomes 2 3 4 5. This once becomes going to append to the end because it's left rotated, so it becomes 1 becomes go to here. Again do a left rotations, this 2 is going to append to the very end, right? So it becomes 3 4 5 1 2, right? Do a left rotations again for more understanding. Sure man, why not? 4 5 1 2 3. So that is my left rotations by thrice. How many times we did? 1 2 thrice. Yes, after thrice left rotations my array becomes 4 5 1 2 3. Clear, right? Now go to the problem statement again. Following, guys, everyone's following, right? If any particular points, if you guys have any problems, feel free to put it on the where you can put on the chat box. Put it on the chat box, right? And if you guys are understanding, please put a like. So this basically means a lot to me. Please basically put a like on the video. Please man, please, those who are basically here with me, please put a like. Right? Thank you so much. Okay, so Now what they are basically looking for, given an array nums, after possibly rotations an integer target, return the index target if it is in nums, or -1 if it is not in nums. Same problems, but on the earlier problem the array is monotonically increasing, but here initially we have the monotonic increasing elements, but our array is somehow left rotated by some unknown index. So that's the reasons. Do you guys feel that the very basic template is going to be work? The templates that we are prepared is going to be work here, exactly work here. So these 5 problems that we solve, guys, is kind of a itself the 5 variants of binary search problems that any on the interview you guys can face. So that is the maximum 5 variants of binary search that we are going to solve. If you have mastered all the 5 variants, you are never ever going to get any rejections, at least the problems on binary search. That assurity I am going to give you guys. So for sure, simple binary search is not going to work here. Agree, right? So now let's try to build our algo. Can we trim our search scope by based on the certain observations? So when we are basically defining our mid, just one observation, please focus on this observation, guys, so when we are at any particular mid, so let's suppose I am at 1. So when we are at any particular mid, at any particular mid on the left rotated array, your that is the fundamental observations. Either your left portion, or your right portion, including your mid is sorted for sure. That is the star key observations you guys have to put. So let's consider any arbitrary index. So if I am at this mid, if my left portions including my mid, so my mid is here, my left is here, if my left portion is sorted, no. Is my right portion is sorted? Yes. So take 2. 2, if your mid is 2 and you are basically looking, let's suppose your left at this index L and your right is at this index, this portion is sorted? No. 2 to 3 is sorted? Yes. If you are at 5, if your mid is at 5, let's suppose your left is at 4 and your right is at 3, then 5 to 3, is this 5 to 3 is sorted? No. If your 4 to 5 is sorted? Yes. So you can try to land to any particular index to this left sorted array. You can try to land to any index by including that mid to your right or that mid to your left. Your either of the segment is bound to be sorted. Either of your segment is bound to be sorted. That is the key observations of this particular algo. I guess you guys are able to understand. If not, then put something on the chat so that I can get it. Some of you guys not able to understand, but that is the fundamentals. You guys, okay man, Pratik, you man are running a bit late. So we are basically solving these problems. Search in a rotated array. Lead code 33. Search in rotated array. You can search these problems and you guys can, Pratik, you can just go over the problems. Right? These problems we are solving. So those who are there, are you guys agreeing? either my left portions or either my right portions, of the mid is bound to be sorted. Now with this, can we try to start writing the code? The same template that we are writing, can we try to write it? So we know, including my mid, either my left is sorted or my right is sorted. You can take any example and you will try to land to any of the mid, and you will definitely understand, you will definitely get the same intuitions that either of your left part or either your right part of the left rotated sorted array is bound to be, including your mid, bound to be sorted, either of your left, either of your right. Yes. So now start writing our very generic template. Can we just see, guys? We will just try to fit our template with this algo, with our template with the observations. N we have defined left, right, start with 0, n minus 1, agree. Same template while my left less than equals to right, my mid is going to be left plus right by 2, right shift by 1 is basically 2 its half, already discussed. Now the game. Now what is the game? Tell me guys. Now the game is either your left part is sorted or your right part is sorted. But before that, first check if my nums of mid is target. If my nums of mid is equals to target, then I think we have done. Return your mid. Very realistic basically point. We just find our mid equals to target. Very I have to say very best case that we all are basically looking for. We just find our mid with the target, right? Yes. If it is not, can I use that intuitions? Either my left part or my right part should be sorted, including mid. How we can check? If my nums of wherever my left to my nums of mid, is this portion is sorted or not? Right? We can check. Any of my portion should be sorted. So if my left portion is sorted, then I am going to check if my target is lying on the left portion. If my target is lying to my left portion is basically nums of L to nums of mid, and my target is lying within that boundary, my left portion is sorted and my target is lying within the boundary, do I have to search on the right? Can we trim down our right search scope? Yes man, trim down. Right equals to mid minus 1. Trimmed my right search scope at all. Completely trim down my right search scope. Else trim down your left search scope. Else should be mid plus 1, right? Else so that means my left part is not sorted, so that means my right part is bound to be sorted. Now mid to right is sorted. Now same check, if my nums of mid less than equals to target is lying to my nums of R, so it is lying to my right part, so trim down left. Left equals to mid plus 1. Left is eliminated. Left is completely eliminated. Else trim down right. Right equals to mid minus 1. And with this binary search, if we are not able to find the target, return a -1. That's it. Quick compilation we are doing. Any one of you, if not able to understand on any part, please put your ask on the comment section. Please ask now only. Quick submissions. Is it working fine? Should be absolutely fine, and we got a accepted for sure with 100% faster than all the submissions. It's also taking 0 millisecond. two problems solved with 0 millisecond. Our code is not taking at all time. Quick time complexity analysis we can do. What do you guys see? What is the time complexity? Same, right? DC is nothing but big O of log n, big O of space complexity. Do you guys see we are using any extra space? Space complexity also of big O of 1. See guys, we solve two industry level. First one is not an industry level problems like on not a product based company problems that you can expect on the interview, but these problems is for sure you can expect. The key observation is either of your left part or either of your right part should be sorted, either your left part or either your right part should be sorted. Is it clear? Is it clear to everyone? Is it clear to every one of you? Every one of you. Let me just quickly check off your chat. It's clear, right? I'm hoping it's clear. Hi Sitabja. Hi Sitabja. Oh, great man. You are also from KGC. I am also from KGC. Yes, KGC. Yes, Sitabja, like I would highly suggest to share the videos to like college channels, like all the department channels that we have it, so that like peoples from all every one of our college should get the benefits of this. And best of luck, Sitabja. I hope you will definitely get some valuable knowledge from this video. Right? Right? So please share Sitabja to your to our college channels, to all the department channels, so that people can join and they can also going to get most of it. Right? Yes, I think it's clear, guys, right? There is just one observations, and with this we have knocked down two problems. Basically, first problems so is very simple. These problems with this one observations we have knocked down. Okay, let's move forward. Let's move forward. Sure. Let's move forward. The next problems is find peak elements. So these problems is asked to one of my SD2 interview rounds of one of the MAANG company on the first preliminary DSA round. First preliminary DSA rounds, one of the MAANG company has asked me exact same problems of these find peak elements. So it is indeed an important problem for sure. It is indeed an important problem for sure. So the problems that we are solving, no guys, so every problems has a key observations. Without this so the first template that we have built, with that template you can solve 90 to 95% problems, but this observation based problems is basically making a kind of challenging on the interview. So that's the reasons we have targeted this, what can I say, this kind of a like interview specific, this observation specific problems, so that you are not going to mess up on your interview to this observation problems if you are going to face on the binary search. Right? Yes. So let's just quickly go with the problem statement. A peak element is an element that is strictly greater than its neighbor. A peak element is an element which is strictly greater than its neighbor. Given a zero index integer array nums, find the peak elements and return its index if the array contains multiple peaks. Returns the index to any of the peaks. If it contains multiple peaks, then you can return any of them. You may imagine that nums of -1, that is there is an arbitrary index of -1, nums of -1 and nums of n, the indexes, this indexes is already a very negligible value. So if you are going to compare with if let's suppose you are at very first index and you are going to consider if it is a peak. So if I am just quickly go to our OneNote, sorry, not on OneNote, this Miro things. So what I am stating, what I'm this particular lines basically stating. So if you are at this particular portions of your searching, and if you are basically finding if it is a peak or not. So peak means, so definitions of peak means it should be higher than of higher than its left, and my peak, so this is my peak and it should be higher than its right. So that is the definitions of peak. So when you are at this particular index, so you may in the doubt that it don't have a left at all, right? It don't have a left at all, but it is higher than its right. It's higher than its right. So can I consider it as a peak? So by definitions, your left, when you are at very starting of the index, your left is lying at minus infinity. So everyone is greater than your minus infinity. So yes, true. You can consider it as a peak. Similarly, when you are at very right boundary and you are checking this elements is higher than your left, I don't have anyone to my right. So that means you have a negative infinity. So negative infinity at your right. So these elements also you can consider to your peak. You can consider to it as an peak, right? So that is the things the problems is basically trying to say you. Clear, right? So we have to return the index of any of peak elements from, if there are multiple peaks, you can return any of them. You can return any of them. You can return any of them. Give 1 to 2 minutes, guys, to think about it. Take some time. Take some time on the thinking. And if you guys have some concrete view, then put your intuitions on the chatbot also, on the chat box quickly. If you have some observations, if you identified some observations, put this on the chat box quickly. Okay, any observations? No observation. How so? Put any observation, guys. We solved two problems and you guys should be have some observations. Anyone have any observation? Everyone is silent. No observation. Very sad. I am kind of upset. Put something. Who are actively putting? Let me see. E Ila Na H Ramu Dogbox Sitabja Patik Gajanan Ramu. Anyone? Any thought? Okay, Ramu has one thought. Left is smaller than mid. Go for left. Absolutely yes. Absolutely yes. Very nicely done. Very nicely done. Have you solved these problems earlier? Have you solved these problems earlier? Or you defined here? You defined here. You defined with now only. You defined with now only. What is the case? What is the case, Ramu? but this is the correct answer, guys. This is the correct answer. This is the correct answer for sure. This is the correct answer for sure. So I hope like you defined, no matter like you have the understanding of these intuitions, man, you are in very good state. You are in very good state, because that is the intuitions basically need to solve it out. That is the intuitions we need to put here to solve it out. To solve it out. Right? Right? That is the observations you have to put to solve it out. Right? So now, yes, go to with the Ramu's intuitions. Go to with the Ramu's intuitions. So what actually Ramu is stating? What actually Ramu is stating? He's stating if my mid is smaller than left, then then search for left. Search for left. So how actually this is work? So now we have some. Now we have some random things. Now we don't have any monotonic sequence, right? So the very base of to use any binary search, our search scope should be monotonic in nature. But here our search scope is not a monotonic in nature. So what? But there can be multiple peak. There can be multiple peak. Now what Ramu basically stating, if my mid is at an index, let's suppose my mid is here, and I am able to observe my left is higher, then go to left. If my right is higher, go to right. So that is the observations which Ramu is able to come up with. So what Ramu is stating, omit your entire right portions if you identify your left portions is higher than your mid. So we omit it. So now we have the search scope of this, right? So now you guys might think that we have some peak to my right which we just going to get rid of. Which we just going to get rid of. Is it correct? Yes, you guys are also correct. But in these problems we have the liberty, we can return any of the peaks. So we omitted all the peaks to my right, and we are going to go with the left. So on the left, initially let's suppose we have the search scope of this, and with this search scope we land this mid. Again my left is higher, so we omitted all the search scope, and we are searching on this. We are searching on this to this. Mid is here, again left is higher, we have omitted this, and we are searching till this. Let's suppose my mid is this, my mid is smaller than my mid is my mid is smaller than my left. On left I don't have anyone, I don't have anyone's, right? So if my right is small, so if we don't have anyone's to my left, if I don't have anyone's to my left, so that means on left I have infinity. So my current elements is greater than my left. Is it greater than to its right? No. So then omit the search scope, land here. Yes. So we are with single elements. We are with single elements, which is for sure a pick. So we can return the index. So why actually it works? The main funda is, let's suppose what we are doing, we are blindly eliminating one of the search scope. We are blindly eliminating one of the search scope. So when you are at this index, when we are stating my left is higher, maybe on left, you guys, the only problems that you guys are getting, maybe on my left there is no peak at all. Then by omitting your right, you are losing your peak at all. You might going to lose your peak at all, but that is not the case, man, because I know these elements can be a pick because it is higher than its right part. So I just need to check if it is higher than its left part, then we definitely have a pick in which we are going to jump to our search scope. We have a pick, so we can identify that pick. So but you guys may ask, maybe its left is higher, its left is higher. If its left is higher, then also we are good. No, then also we are good, right? Because on that particular case, this element is going to consider as a pick, this element is going to consider as a pick, right? This element is going to consider as a pick. So on either case, you are not going to. So if your array is something like this, so on very worst case, you are going to get your pick to the very start of the elements, because on left it has infinity and its right is going to get its the smaller value, and your peak is at the very start. So that means if you are going to go with this greedy implementation, you have just going to search your mid, and if your left is higher, blindly go to with that. If your right is higher, blindly go to with your right. Omit of other parts, you will definitely get your answer. You will definitely get your answer. So that is the key observations. That is the key observations. With these observations, can we guys start to quickly code it out? Can we guys quickly start to code it out? So again, what? Define n should be len of my nums, n should be len of my nums, left right should be 0, n minus 1, while my left less than equals to my right. Then point out your mid, on this. We should have a because this nums of I not equals to nums of I plus 1, so that means you definitely have a pick, to your array elements for sure. Same template, left plus right by 2, defined our mid. Now define your left initially. Why I am doing so, you guys will definitely get with when I am just going to complete the code. My left should be sys dot max size, so that means negative infinity. Right should be also my minus sys dot max size, negative infinity. Left, if do I have someone to my left, of whom? To my mid. If my mid is 1 greater than equals to 0, so someone in mid, so update your left to be nums of mid minus 1, right? Elif, same, sorry, not elif. If do I have someone to my right, mid plus 1 less than n, so that means I have a right, right should be nums of mid plus 1, right? Now check, if my left less than, what is the conditions? It should be higher than both. Nums of mid, my nums of mid is higher to its left and to its right. Condition satisfied, it's a pick, return mid. Else you should go, if your left, you can see your left is higher, so pick lies on the left side, pick lies on the left part. Omit your right to be mid minus 1, omit your right segment. If right is higher than my nums of mid, so omit your left part, left should be mid plus 1. Quick compilation check we can do. It looks good to me only. Fine, right? So what we did, we defined our left right to be 0 to n minus 1, mid equals to left plus right. by 2, left, right, infinity definitions, left exist, left. So this means my, what this means, meat has a left. This means meat has a right, right? If my meat has a left, then update your left to be that value. If your meat has a right, update your right to that value. And if it is satisfies the peak conditions, return the meat. If my left is higher, go to your if your left is higher, go to your left part by eliminating your right side scope at all. If your left is higher, go to your left part, eliminating your right side scope at all. As simple as that. Compilations we did. Quick submit, can we do? Let's do. Hopefully we will get an AC. Hopefully. Yes, man, it's an indeed AC. 3 problems in series without a zero wrong answer. We are doing amazing, man. We are doing amazing. So time complexity is for sure. Tell me, guys. Big of login everything we are doing on binary search only. Space complexity. Are we using any extra space? Nope. It's exactly a big of 1 for sure. We are using our template. See guys, we are using the first template that we built on the very first problems, and we are using the same template repeatedly to all the 3 problems, and we solved one of the problems that has asked on one of the MAANG level companies on first DSA preliminary round on SD2 interview. So these problems has asked on one of my SD2 interview rounds of one of the MAANG companies first DSA preliminary round. So I hope you guys got the gist of the problems. If you understood, let me quickly check your chat, guys. If you guys are able to understand, how many of you are following now? I know with the difficulty, crowd should gets dropped. I know the things with the difficulty, crowd should get dropped, but only those will going to get the crown who is going to follow till end, because till end we are going to solve two more most important industry problems that we are going to solve. One is binary search on answer, and another one is like grid versions of binary search. These two are like, next two is also like equally important. Like the binary search on answer, I have to say is the most important ones. This particular template, you have to understand, you have to get it. Like this binary search on answer is basically most commonly asked problems, man. This is I so that's the reason I am basically asking on every problems, and I am basically repeatedly asking, are you guys following? Is it clear to you? Is the things that we learned till now, if all the 3 problems is clear to you? Any doubt, ask now only. Any doubt, ask now only. Right? Right? Can we guys quickly take a break? What do you guys see? Can we take a 5 minutes break? Just 5 minutes. We can back at 9:05. 9:05. Yes, we can. Let's just take a 2 to 5 minutes break. I just need a quick refreshment. We solved 3 problems without a single wrong answer, single TLE. All the 3 problems with 0 milliseconds, beat 100%. Beat 100%. And all the 3 problems is kind of a master level binary search topic problems. One is asked on a MAANG company to myself itself. Right? Let's take a quick break. BRB. We are going to go to BRB. Mute ourselves. Hello guys, hello. Confirm me guys, are you able to hear me? We are back. Actually, we have to complete it a little quick because dinner time is almost coming. Yes, we have to go for dinner, right? So let's just quickly stretch down for the two problems very quickly we'll do. Very quickly, very quickly we'll do. Because we have built our foundations. The foundational problems has done. So now the next two problems is going to be very quick. Very quick we will do. Right? I hope on setup part there is no issue. You guys are able to hear me. You guys are able to see my screen. You guys are also able to see myself. Three things fine. Three things fine. If three things fine, then can you put a, can you please guys put a, can you guys please put a, what you guys can put? Can you guys please put a, can you guys please put a thumbs up? Can you guys please put a thumbs up? Please guys, please put a thumbs up. Can you guys please put a thumbs up? Any one of you, any one of you. Okay, okay. Okay, so yes, we can then quickly start now. I think on setup, but there should not be any issue. There should not be any issue, right? So yes, we got yes from TG, yes from Manik, right? Then I guess we can start. So yes, so where we are, so we are at on our fourth problems of the day. Fourth problems of the day. So on the fourth problems, we have search a 2D matrix. So this problems I feel so it's going to get a little easier compared to the last two problems. It's going to, we can use our template blindly here. So you are given an m cross n integer matrix of the following two properties. Each row is sorted in non-decreasing order. Each row is sorted in non-decreasing order. The first integers of each row is greater than the last integer of the previous row. So what actually it means? What actually it means? Let's me quickly simplify this two statement to you guys. Let's just quickly simplified these statements to you guys. So what actually this means, so in this matrix, this matrix is sorted in row wise, and the next elements of the next row first elements, the next row first elements is always higher than the previous row's last element. So it is sorted like on zigzag format. It is sorted like on this zigzag format from smaller to larger, right? That is the things that they are basically trying to explain on these two lines, right? Clear, very clear. If not, then I would highly encourage to you guys to just go read the problem statement twice. Right? So yes, so the matrix is sorted on the way that we have just saw, in non-decreasing order. Given an integer at a target, return true if the target is in the matrix or false otherwise. You must write a solutions of big of log m cross n time complexity, right? Very clear hints what we have to write. Very clear hints, right? What we have to write: define our n and m comma n should be my length of my matrix, right? Or maybe I can define it reverse, n comma m matrix, length of my matrix of 0, length of my matrix of 0, yes, right? Then my left and right, left should be start at 0th index and right should be what is the size of my entire matrix is nothing but n cross m minus 1, n cross m minus 1, right? N cross m minus 1, that is the size, that is the size of my matrix, that is the size of my matrix, and that is the size of my binary search scope here, search scope here. Same template, while my left less than equals to my right, mid should be my left plus right by 2, while my now the game is how we can define our row number and column number. My row number is always going to be mid. What is the row number? What is the row number? Tell me guys, tell me quickly, tell me how we can define our row number. How we can define our row number? If it is an n cross m matrix, if it is an n cross m matrix, there is a formula. My row and col, one is divided by m, another one is, that is the column size, and another one is going to the modulo. It's an integer divisions, and my column is going to get the modulo of it. If you are in the 0, if you are searching on 0 into m cross n, and if it is an m cross n box, then your row and column number is always going to get, you can achieve it with the formula. Now once we achieved, what we have to check, if my matrix of row and col is less than my target, let's first go with the target one, equals to my target, return true from here itself. If my matrix of row comma col is smaller than my target, then my target is lying to some higher part, then trim down your left search scope. How you can trim down? Move your left to mid plus 1, else move your right part to mid minus 1, move your right part to mid minus 1. You just have to do this game simply like this, and finally if with the entire binary search you are not able to identify this, then return a false after that. Yes, that is the things you just have to write. Quick compilations, should it works fine, pass the sample test case, quick submissions, should be an AC. Yes, it's indeed an AC, and with 4 streak we are solving the problems with 0 millisecond. Our code is not going to take the time at all. The time complexity, exactly the time the interviewer is looking for from you is big of log m cross n, and on space complexity is bound to be big of 1, right? That is the space and time. I think this is a kind of more easier versions than the past 2 problems that we have solved. Here we just have to write our template. The main game is to how we can basically define a row and column number. So that is the formula. You can just rememberize or you can define also. Try to rememberize, because on interview time it's going to kind of very difficult to define the formula. So kind of try to rememberize the formula, and for understanding or intuitions you can write this formula. Take a m cross n grid, n cross m size grid, and put the formula to try to land your pencil to a pen or pencil at any arbitrary points. Your numbering from 0 to n cross m minus 1, the grid indexing, and try to put your pen or pencil on any particular index and try to define the row and column number with this formula. You will definitely get the gist. So once you defined your row and column number, then it's very standard. Either left elimination or right elimination. If you are not able to find, then we are returning a false. This I feel a kind of a easier versions of the past two problems until you don't know how to define row and column numbers of the grid by like the mathematical smart mathematics on the runtime itself. Then it's kind of a challenging, but I think like if you know, then it's a kind of very easy problems, right? Any question on the chat? Are we good? Are we good here? Are we good? Any problem? Any question, or we are good? Any question, or we good? Any question, or we good? Ramu, P, Manik, Sita, Bucha. Anyone's? Any any doubt? Good. Okay. Good from Manik. Fine. Okay, so now we are going to solve the very last problems of our today's sheet, that is of cocoa eating bananas. This is a kind of indeed, this I have to say, an indeed important problems. This is an indeed important problems for sure. This here we are basically doing the binary search on answer. So this is lying on binary search on answer. Let's quickly understand the problem statement. So Coco loves to eat bananas. There are n pile of bananas. The ith piles has piles I bananas. The guards have gone and will come back in 8 hours. So we have a piles of bananas. So every piles is holding a set of bananas, and the guards have gone and will come back after how many times? After 8 hours. The guard will come back after 8 hours. And Coco can decide her bananas per hour eating speed, that is K. He can decide his eating speed. Sorry, she can decide his bananas eating speed per hour, and each hour she choose some piles of bananas and eats K bananas from that pile. If the pile has less than K bananas, she eat all of them instead and will not eat any more bananas during this hour. Right? Coco likes to eat slowly but still wants to finish eating all the bananas before the guard returns. And we know the guard returns after 8 hours. The guard returns after 8 hours. So within 8 hours, with a eating speed, with a rate of eating speed, Coco basically eat bananas in slowly with the minimum bananas she has to consume per hour, so that she can complete all the bananas. So return the minimum integer K such that she can eat all the bananas within 8 hours. So now quickly jump to our OneNote where we are this Miro. So the key observation is we have some piles of bananas. So these are piles of bananas. So that is first piles. Then we have second piles of banana. This is the third piles. This has more bananas. So like this we have set of piles of bananas. So what actually this problem is basically stating, you can define your rate of consumption and you can eat per hour that many bananas. So let's suppose you have defined your speed of eating your banana as K equals to 2. So that means in 1 hour you are consuming 2 bananas. So how many times you are going to take to complete this pile? You are going to take 6 bananas there, and you are consuming 2 bananas per hour. So you need 3 hours to entirely consume this particular piles. So if you are eating a speed of 3, we have total 6 bananas. How many times you are going to take to entirely eliminate these piles? 2 hours, right? 2 hours you are going to take. If you are eating a speed of 4, how many times you are going to take to eat entire piles? You are going to take something 1 point something something, 1 point something something, right? 1 point something something. So now in this problem statement there is a very strong lines. If you followed, then if you are going to have some time with this particular hour, you are not allowed to do, you are not allowed, let's suppose you are basically consuming bananas at a speed of 7, and we have 6 bananas to this particular pile. So we are going to consume this entire piles to some 0 point some 987 some time less than 1 hour. So you guys may be a kind of greedy and try to consuming the next piles to that particular hour only. No, you can't do. If you are completed the piles within a specific hours within the specific hours, then you should lie without eating more bananas with this particular hour. So that's the reasons when we are eating a speed of 4, we are going to consuming a time of 1 point something something hour cocoa is going to consuming, but cocoa have to stay 2 hours only. 2 hours only. What is the next biggest integer? That many times cocoa has to stay on this particular piles before she can move to the next piles. So that is the constant. If you are consuming all the bananas within the frame times, you should have to lie until your hours are going to get completed. Post that only you can go to the next piles. Post that only you can go to the next piles, right? I think the problem statement is clear. Now there is a very key observations on these problems. So here you can see your piles length is less than h. Your piles length is less than h. So that means if what is the maximum speed? So are you guys able to see any monotonic sequence here? Are you guys able to see? My k, what is the minimum speed cocoa can eat the banana? Cocoa can eat one banana in 1 hour. That is the very minimum speed cocoa can achieve. And like this, what is the maximum speed cocoa should eat? Cocoa should eat so that she can consuming all the piles within 8 hours. Can I write it? Max of my piles, max of piles. If she is consuming the banana at a speed of max of piles speed, she will definitely consuming all the piles within 8 hours. Why so? Because on the problems it stated your piles length is less than h. So that means she is consuming. So this, what actually this means, if she is set her k at a speed of max of piles, so that means every piles she is going to consuming in 1 hour. Every piles she is going to consuming in 1 hour, because her maximum consumption piles is maximum piles length. So all the piles she may be consuming within 1 hour, but we have to stay on that pile at least 1 hour before jump to the next pile. So she will going to consuming all the piles within 1 hour only. And what is the size? It's nothing but piles dot length. So that many hours she is going to consuming, and on the constant it is basically stating piles dot length is always going to less than smaller than my age. So that means with this way of eating, she is bound to finish her job within guards arriving, before of the guards arriving, right? Agree, totally agree. So now, are you guys able to see any monotonic sequence? So we have to find this k. This is nothing but our answer. So my answer is lying between 1 to max of piles. Inside it, my answer is lying. So is it a monotonic sequence? So no, sorry, we are not able to correlate. Why we actually have to define it as a crown of monotonic sequence. So now I am going to give you the feel of how binary search in answer is actually going to help here. So max of piles, you are basically iterating in max of piles. Let's suppose you have arbitrarily defined a speed of k equals to 7. Now you just have to check with k equals to 7 speed with, if you are eating 7 bananas per hour, are you able to eat all the bananas within 8 hours? Within 8 hours. If your answer is coming as two answer, boolean, either yes, either yes. If it is yes, can I say with k equals to 8, k equals to 9, k equals to 10, it's always going to satisfy. It's always going to satisfy. So my right part 7, 8, 9, 10, it's always going to satisfy with more speed. I definitely able to consuming the entire piles, all the piles within 8 hours, for sure, for sure. So on right side, any value of k, my answer should exist, but we have to search for minimum. So we can eliminate the right and we can search for the minimum. So let's suppose with k equals to 2, k equals to 2, your answer is coming as no. So that means with k equals to no, you are going to consuming more than 8 hours, so you then again greedily go. Now your search scope becomes from 2 to 7. Inside this there is something. Now your search scope becomes 2 to 7, 2 to 7. Now let's suppose you have found 5. Now you are checking with this 5, are you able to hit? Let's suppose answer is coming yes. So with 6 valid, 7 valid, you will definitely able to consuming the bananas within 8 hours. So with 5 we are going to get it. Now trim search scope 2 to 4. You have defined it's 3. No, not possible. Search scope trimmed, your search scope becomes 3 to 4. Your pointer becomes, sorry, not 3 to 4, it becomes 4 to 4, because on 3 it's no, right? So your mid is going to move to this left and you have only single elements. So on 4 to 4, let's suppose you got an yes. If you got an yes, then that is the minimum. On single elements, that is bound to be the minimum, right? So that is on the high levels the algo should be work. Now we have to just define how actually our is possible functions with this particular k, how we can smartly check if it is possible to eat the bananas. If it is possible to eat the bananas, we will do on the coding itself. So let me just quickly write the our template of the binary search first. L R should start. Let's first define our n also. N should be my lane of nums. L should be my lane of nums 0, n minus 1, while my left less than equals to right, I will going to define my mid. Sorry, here right is n minus 1 kya? No guys, no. What should be my right? My left is also wrong. My left should be 1, right? At very minimum speed, Coco can eat at a speed of 1, right? And what is the maximum speed she can achieve? Max of piles. With this, she would definitely going to consuming all the bananas within the time frame. And my answer should be, let's start with minus 1. And if my mid, how we can define? Same way, mid define, no change. L should be left plus right by 1. If is possible with this speed, I will define this function. Let's suppose there is a black box. Let's suppose we have a black box of is possible functions, which is basically returning me true or false. We will understand what actually we have to write. Inside this black box functions is possible. If my is possible is returning with this speed, with this mid consumption of bananas per hour, if my answer is coming true, so that means with this consumptions valid, you are going to end it within 8 hours. Then update your answer to be this particular mid value and trim down your right search scope, because your answer should be going to satisfy to its right for sure. Trim down your right search scope and try to find more minimum hours, more minimum k value to its left, So we have trimmed our right search scope. Else we have to trim down our left search scope. That's it. How to trim? Left equals to mid plus 1. Finally, we can return our answer. That is the problem, guys. That is the problems we just have to write. Now, the main game is to define our black box functions. Def is possible, it's going to be very simple, it's going to be very simple. That is nothing but my speed. With this speed I am eating the bananas. Time, that is the time. I can start with my time equals to 0 and I am going to iterate for each in my piles, each in piles. What is the time it's going to add to my time? It's nothing but time plus equals to what is the time it's going to contribute to my answer? It's nothing but math.ceil. Why math.ceil? We have already discussed. Because if it is going to take 1.8 hours, then we have to take 2 hours altogether. We have to take 2 hours altogether. Math.ceil of each by what is the speed we are consuming the bananas. The speed that we are consuming the bananas. Time plus equals to math.ceil of each by speed. Now at any particular time, if my time is more than my h hours, can we return a false then and there? So that means we are not able to satisfy, we are not able to consuming all the bananas within h hours. So return false then and there. Else return a true afterwards. Else return a true afterwards. That is should be your is possible bool functions. Is possible bool functions should gets looks like. As simple as that. As simple as that. Clear guys? Clear, right? Let's do a quick compilations. Any doubt? Ask now. Any doubt? Ask now. What is? Okay. Nums. I use nums. So it should be piles. Should be piles. Should get compiled correctly. Yes. 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 It's coming fine. Quick submissions. Should get and give me an AC in the row, man. I am very waiting for it. It's an AC. It's also an accepted for sure. Now quickly we can do the time complexity analysis. The time complexity, the binary search approach is always going to take a kind of big of in log n. Why so? Why so? Why so? Because my binary search is for sure going to consuming a time of big of log n, and inside that this function call is there. Is possible function is going to iterate at worst case a single for loop which is going to consuming a time of big of n, which is going to consuming a time of big of n, right? So the time complexity is going to then on that case big of n log n. If there is a nesting in your any particular nesting is happening, then you just have to multiply the particular segment code time complexity. Big of n is one segment complexity and it's happening inside a log n box. So the time complexity is become big of n log n. And what is the space complexity? Are you guys see we are using any extra space? Nope. It's big of 1. It's constant for sure. That is the time complexity of this particular binary search on answer problems. That is a kind of a master level problems on binary search at very difficult that you can expect, and I tried my best to explain to you guys in the live. So if you guys are able to understand, please put an UD, please put an quick UD, or if you guys have any doubt, then please put your doubt on the comment section. If you guys have any doubt, please put your doubt on the comment section. If not, I think you guys have understood. If you guys have any doubt, no, then you can also put on the comment also. I will pick the comments, I will iterate to the comment also and try to get it resolved, try to answer your comments. But yeah, this is kind of a master level problems. In live we have solved, we have write every lines of code in the live itself. So I think it's bound to be clear to you guys. There should not be any exception. It's bound to be clear to you guys. Right? Then any question apart from this? Any question? If you guys understand all the things. If you understand all the 4 problems, then put an UD in the comment section. Put an UD. All those who are following, if are you guys understood all the 4 problems, all the 5 problems that you have solved. From Manik, it's very good explanations. Understand all 5. Great, man, great. It means a lot to me. Cool, cool, cool. I think then we can wrap our then this particular sessions. Can we wrap? Can we wrap if we don't have any further question? If you guys have any query, no, then please put it on the comment section also. I will put the queries and answer those for sure. Because binary search is kind of a can't miss topics in interview perspective, and we solve like really toughest problems of the binary search that you can face on the interview. And some of the problems is I faced on SD2 interview. So these problems you can't miss at all. These all are highly important on interview perspective, right? Right. So I think we are good here, right? We don't have any further questions. We have a clean chat. If Manik has understand all 5, and I am hope you guys also, all of you guys have understood all the 5, right? Right. So with this note, we are going to wrapping this. With this note, we are going to wrapping this, right? Right. I am here with 1 to 2 minutes more. So if you guys have any problems, then just put it in the live chat. Then I am just quickly answer with next 2 to 3 minutes. I will going to answer it next 2 to 3 minutes. If you have any further things, I am going to go to on the ending mode, but I am here for another 2 to 3 minutes.